We're going to complete skill practice 7
using only identities. So given that sine of negative 5/13 is in quadrant 4, so let's think about quadrant 4 really quickly. In quadrant 4, our x's are positive and our y's are negative. Now I want to find cosine and tangent. I know that the quotient identity says that the tangent of theta is equal to the sine of theta over cosine of theta. I have sine of theta. Let me find cosine of theta. Well, and the Pythagorean identity says that the sine squared of theta plus the cosine squared of theta equals 1. Let's use that one to find cosine. That means that the cosine squared of theta is equal to 1 minus sine squared of theta, or cosine of theta is equal to the square root of 1 minus sine squared of theta. Using the sine value that we have, that's negative 5/13 squared. Cosine of theta is then equal to 1 minus 25/169. So I'm going to say 1 is 169/169. A negative squared is a positive. 5 squared is 25. 13 squared is 169. So that's going to give me the cosine of theta is equal to 169 minus 25 is 144/169, which winds up being the square root of 144 over the square root of 169, or the cosine of theta is equal to 12/13. So now I'm going to find the tangent using the fact that sine is negative 5/13 divided by 12/13. And just to be clear, the cosine is positive in this case because my x is positive in quadrant 4. You always want to do a sign check when you're using an identity. Simplifying using division of fraction rules means I can multiply by the reciprocal. 13s will cancel, and the tangent of theta is equal to negative 5/12. Without using identities, you could have labeled your triangle, found your missing side, which is actually a Pythagorean triple value of 12, and then calculated cosine of theta to be 12/13 and tangent to be negative 5/12.